Hi guys, it's me again, Angie. For today's video, I'm going to discuss about the summary of chapter 1 to 11. So for class overview, Cisco courses deal with networking and network support, covering topics such as network fundamentals, routing concepts, and remote access. For essential information, the Cisco course curriculum is universal across the nation, with many colleges offering multi-course certificate programs that prepare students for a number of Cisco certifications. Depending on level, these Cisco certifications can help recipients qualify for entry-level, intermediate, or advanced positions in networking and information technology. Here is an outline of common concepts taught in Cisco courses: routing protocols and concepts, scaling networks, implementing Cisco IP routing, frame relay interfaces, and connecting networks. For Chapter 1, the globalization of the Internet has ushered in new forms of communication that empower individuals to create information that can be accessed by a global audience. Some forms of communication include texting, social media, and collaboration tools, wikis, podcasting, peer-to-peer file sharing. Texting enables instant real-time communication between two or more people. Social media consists of interactive websites where people and communities create and share user-generated content with friends, family, peers, and the world. Collaboration tools without the constraints of location or time zone. Collaboration tools allow individuals to communicate with each other, often across real-time interactive video. Blogs, which is an abbreviation of the word weblogs, are web pages that are easy to update and edit. Unlike commercial websites, blogs give anyone a means to communicate their thoughts to a global audience without technical knowledge of web design. Wikis are web pages that groups of people can edit and view together, whereas a blog is more of an individual, personal journal. A wiki is a group creation. As such, it may be subject to more extensive review and editing. Many businesses use wikis as their internal collaboration tool. Next is podcasting. Podcasting allows people to deliver their audio recordings to a wide audience. The audio file is placed on a website or web or wiki where others can download it and play the recording on their computers, laptops, and other mobile devices. The next one is peer-to-peer file sharing, which allows people to share files with each other without having to store and download them from a central server. The user joins the peer-to-peer network by simply installing the peer-to-peer software. This has not been embraced by everyone. Many people are concerned about violating the laws of copyrighted materials. Networks support the way we play. The internet is used for traditional forms of entertainment. We listen to recording artists, preview or view motion pictures, read entire books, and download materials for future offline access. Live sporting events and concerts can be experienced as they are happening or recorded and viewed on demand. Networks of many sizes. Networks come in all sizes. They can range from simple networks consisting of two computers to networks connecting millions of devices. Simple networks installed in homes enable sharing of resources such as printers, documents, pictures, and music between a few local computers. Home office networks and small office networks are often set up by individuals that work from a home or a remote office and need to connect to a corporate network or other centralized resources. In businesses and large organizations, networks can be used on an even broader scale to provide consolidation, storage, and access to information on network servers. So for chapter 2, operating systems. All end devices and networks devices require an operating system. The portion of the OS that interacts directly with computer hardware is known as the kernel. The portion that interfaces with applications and the user is known as the shell. The user can interact with the shell using a command line interface or the CLI, or a graphical user interface, or also known as the GUI. A GUI interface such as Windows, OS X, Apple, iOS, or Android allows the user to interact with the system using an environment of graphical icons, menus, and windows. However, GUIs may not always be able to provide all the features available at the CLI. GUIs can also fail, crash, or simply not operate as specified. For these reasons, networks devices are typically accessed through a CLI. The CLI is less resource intensive and very stable when compared to a GUI. So, why is OS important? Network operating systems are similar to a PC operating system. Through a GUI, a PC operating system enables the user to use a mouse to make selections and run programs, enter text and text-based commands, and view output on a monitor. A CLI-based network operating system like the Cisco iOS on a switch or router enables a network technician to use a keyboard to run CLI-based network programs, use a keyboard to enter text and text-based commands, and to view an output on the monitor. Cisco networking devices run particular versions of the Cisco iOS. The iOS version is dependent on the type of device being used and the required features. While all devices come with a default iOS and feature set, it is possible to upgrade the iOS version on feature set to obtain additional capabilities. So let's go to the next chapter, chapter 3, communication. Communication fundamentals. A network can be as complex as devices connected across the internet, or as simple as two computers directly connected to one another with a single cable and anything in between. Networks can vary in size, shape, and function. However, simply having a wired or wireless physical connection between end devices is not enough to enable communication. For communication to occur, devices must know how to communicate. People exchange ideas using many different communication methods. However, regardless of the method chosen, all communication methods have three elements in common. The first of these elements is message source or the sender. Message sources are people or electronic devices that need to send a message to other individuals or devices. The second element of communication is the destination or the receiver. The destination receives the message and interprets it. The last element is called the channel, by which it consists of the media that provides the pathway over which the message travels from source to destination. Communication begins with a message or information that must be sent from a source to a destination. The sending of this message, whether by face-to-face communication or over a network, is governed by rules called protocols. These protocols are specific to the type of communication method occurring in our day-to-day personal communication. The rules we use to communicate over one medium, like a telephone call, are not necessarily same as the protocols for using another medium, such as sending a letter. Many different rules or protocols govern all methods of communication that exist in the world today. Rule establishment. Before communicating with one another, individuals must use established rules or agreements to govern the conversation. Protocols are necessary to effective communication. These rules or protocols must be followed in order for the message to be successfully delivered and understood. Protocols must account for the following requirements: an identified sender and receiver, common language and grammar, speed and timing of delivery, confirmation or acknowledgement requirements. So let's move on to the next chapter, Chapter 4, Network Access. To support our communication, the OSI model divides the functions of a data network into layers. Each layer works with the layers above and below to transmit data. Two layers of the OSI model are so closely tied that according to the TCP/IP model, they are in essence one layer. Those two layers are data link layer and the physical layer. On the sending device, it is the role of the data link layer to prepare data for transmission and control how that data accesses the physical media. However, the physical layer controls how the data is transmitted onto the physical media by encoding the binary digits that represent data into signals. On the receiving end, the physical layer receives signals across the connecting media. After decoding the signal back into data, the physical layer passes the frame to the data link layer for acceptance and processing. So we have types of connections. Whether connecting to a local printer in the home or a website is in another country. Before any network communications can occur, a physical connection to a local network must be established. A physical connection can be a wired connection using a cable or a wireless connection using radio waves. In addition to wired connections, many businesses also offer wireless connections for laptops, tablets, and smartphones. With wireless devices, data is transmitted using radio waves. The use of wireless connectivity is common as individuals and business alike discover the advantages of offering this type of service to offer wireless capability. Devices on a wireless network must be connected to a wireless access point or the AP. So we have here chapter 5, the MAC sublayer. The MAC sublayer has two primary responsibilities. It is for data encapsulation and for media access control. Data encapsulation. The data encapsulation process includes frame assembly before transmission and frame disassembly upon reception of a frame. In forming the frame, the MAC layer adds a header and trailer to the network layer PDU. Data encapsulation provides three primary functions: the frame delimiting, addressing, and the error detection. For frame delimiting, the framing process provides important delimiters that are used to identify a group of bits that make up a frame. These delimiting bits provide synchronization between the transmitting and receiving nodes. For addressing, the encapsulation process contains the layer 3 PDU and also provides for data link layer addressing. And for error detection, each frame contains a trailer used to detect any errors in transmissions. Media access control. The second responsibility of the MAC sublayer is media access control. Media access control is responsible for the placement of frames on the media and the removal of frames from the media. As its name implies, it controls access to the media. This sublayer communicates directly with the physical layer. Ethernet evolution. Since the creation of Ethernet is 1973, standards have evolved for specifying faster and more flexible versions of the technology. This ability for Ethernet to improve over time is one of the main reasons it has become so popular. Early versions of Ethernet were relatively slow at 10 Mbps. The latest versions of Ethernet operate at 10 gigabits per second and faster. So the next chapter is chapter 6, the network layer. The network layer or the OSI layer 3 provides services to allow end devices to exchange data across the network. To accomplish this end-to-end transport, the network layer uses four basic processes. Addressing end devices. End devices must be configured with a unique IP address for identification on the network. Encapsulation. The network layer encapsulates the protocol data unit or the PDU from the transport layer into a packet. The encapsulation process adds IP header information, such as the IP address of the source and the destination. Routing. The network layer provides services to direct packets to a destination host on another network. The encapsulation. When the packet arrives at the network layer of the destination host, the host checks the IP header of the packet. If the destination IP address within the header matches its own IP address, the IP header is removed from the packet. After the packet is being encapsulated by the network layer, the resulting layer 4 is passed up to the appropriate service at the transport layer. So the next chapter is chapter 7, IP version 4 communication. A host successfully connected to a network can communicate with other devices is one of three ways: the unicast, the broadcast, and the multicast. These three types of communication are used for different purposes in data networks. In all three cases, the IP version 4 address of the originating host is placed in the packet header as the source address. So the next chapter is chapter 8, broadcast domains. In an Ethernet LAN, devices are broadcast to locate other devices and services. For other devices, a device uses ARP, which sends layer 2 broadcast to a known IP version 4 address on the local network to discover the associated MAC address. For services, a host typically acquires its Internet Protocol version 4 address configuration using the DHCP, which sends broadcast on the local network to locate a DHCP server. So the next chapter is chapter 9, transport layer. Data networks and the internet support the human network by supplying reliable communication between people. On a single device, people can use multiple applications and services such as email, the web, and the instant messages to send messages or retrieve information. Data from each of these applications is packaged, transported, and delivered to the appropriate application on the destination device. The processes described in the OSI transport layer accept data from the application layer and prepare it for addressing at the network layer. A source computer communicates with a receiving computer to decide how to break up data into segments, how to make sure none of the segments get lost, and how to verify all the segments arrive. When thinking about the transport layer, think of a shipping department preparing a single order of multiple packages for delivery. The next chapter is chapter 10, application layer. Applications such as web browsers, online gaming, chatting, emailing friends enable us to send and receive data with relative ease. Typically, we can access and use these applications without knowing how they work. However, for network professionals, it is important to know how an application is able to format, transmit, and interpret messages that are sent and received across the network. The application layer is closest to the end user. It is the layer that provides the interface between the applications used to communicate and the underlying network over which messages are transmitted. So, the last chapter, small network topologies. The majority of businesses are small. It is not surprising then that the majority of networks are also small. A typical small business network with small networks, the design of the network is usually simple. The number and type of devices included are significantly reduced compared to that of a large network. The network topologies typically involve a single router and one or more switches. Small networks may also have wireless access points and IP phones. As for connection to the internet, normally a small network has a single WAN connection provided by DSL cable or an Ethernet connection. Managing a small network requires many of the same skills as those required for managing a larger one. The majority of work is focused on maintenance and troubleshooting of existing equipment, as well as securing devices and information on the network. Device selection for a small network. When implementing a small network, one of the first design considerations is the type of intermediate devices to use to support the network. When selecting the type of intermediate devices, there are a number of factors that need to be considered. The cost, the speed and types of ports interfaces, the expandability, then the operating system features and services. A network device can support certain features and services such as security, quality of service, voice over IP, layer 3 switching, network address translation, dynamic host configuration protocol. Administrators are better able to control access to resources on the network based on IP address when a deterministic IP addressing scheme is used. This can be especially important for hosts that provide resources to the internal network as well as to the external network. Web servers or e-commerce servers play such a role. If the addresses for these resources are not planned and documented, the security and accessibility of the devices are not easily controlled. Each of these device types should be allocated to a logical block of addresses within the address range of the network. So that is all for chapters 1 to 11. Thank you for watching. See you on my next video.